we're going to wrap up Unit 4 with a section on scientific notation. Now, scientific notation is used in chemistry classes as well as some of the other science classes, that's the name. But we use it because it's very convenient for taking really big numbers and really small numbers, positive numbers, and writing them in a more convenient manner. Plus the fact that we can do multiplication and division conveniently when they're written in scientific notation. But first things first, what is scientific notation? One of the quiz shows had the question, what's the distance from the Earth to the Sun, which is 93 million miles approximately, but they didn't write the answer in standard form, like 93 million miles, like I have it written here. They had the answer written in scientific notation. And so this, the contestant not only had to know the answer, 93 million miles, but be able to figure out what that was written in scientific notation. So what is scientific notation? It's a number that is in the form c times 10 to the nth, because we have a base 10 number system, 10 to the nth, where c is a number between 1 and 10. It can equal 1, but it can't equal 10. And then it's an integer. So it could be 0, and it could be negative, and that's why we studied those topics in the last lesson. So I have a couple of numbers here, one kind of big and one kind of small here. This one's much bigger than 10. This is almost 0 here. And I'm going to write them in scientific notation. I'm going to show you one extra step that might make it a little bit more convenient. Since this number here has to be between 1 and 10, and again, it could equal 1 but not 10, I'm going to have to move the decimal point, which is right here on the end, to right here between the 3 and the 7 to make that number between 1 and 10. If I move the decimal point there and drop these zeros, because they won't be necessary anymore, I'll have 3.75. But I have moved the decimal point 1, 2, 3, 4, oops, 4, there we go, 5 places. That's the same as multiplying it by 100 zeros. Notice 5 places, 5 zeros. Okay, now I'm going to write this using exponents because this is a power of 10. This is 3.75 times 10 to the, well, there are 5 zeros. That means there's 5 factors of 10. My exponent is a 5. That's scientific notation. That fits this form where you have a number between 1 and 10 times 10 raised to a power. So I'm going to do the same thing now, only this time I'm going to do this with the much smaller number. I'm going to rewrite this as a product form. So what I'm going to have to do is I'm going to have to move the decimal point, which is right here, all the way over here to the right side of the 7, because then the number becomes just 7. So this is 7 times, but this time I moved it 1, 2, 3, 4, 5, 6 places in the other direction. So I am going to have to multiply this by 0.1234 zeros and the 1 for this 6th place. So 6 digits to the right of the 0, or to the right of the decimal point, and 6 places that I had to move it here. Well, now this is the same as 7 times 10. Now this is a negative exponent that I have to use because this is not a power of, at least a positive power of 10. This is a negative power of 10, and I have it 1, 2, 3, 4, 5, 6 places. I will need a negative 6 as my exponent. Now, writing it in product form sometimes helps, and sometimes I think it does more harm than good. I remember this as a big number, positive exponent, as a small number, negative exponent, and then just count the number of places that you'd have to move the decimal point to determine your exponent. Let's do that on these bottom 4 problems here. The decimal point would be right here. I'm going to have to move it between the 4 and the 1 to make that a number between 1 and 10. Now, how many places did I move it? Well, I moved it 1, 2, 3 places. This is a big number. It's a positive exponent. It's a positive 3. Here, the decimal point's right here. I would have to move it between the 5 and the 2 to make that number between 1 and 10. So it becomes 5.2 times 10 to the, now this is going to be, this is a small number, so this is going to be a negative exponent. I moved it 1, 2, 3, 4 places. This is going to be a negative 4. 5.2 times 10 to the negative 4. Here's a big number again. The decimal point's on the end. I'm going to have to move it between the 1 and the 8. So this would be 1.8 times 10 to a positive exponent of 1, 2, 3, 4, a positive 4. And then my last example over there, I had some smaller numbers, so this is going to be a negative exponent, so I'm going to have to move the decimal point from where it's at to between the 7 and the 4 to make this a number between 1 and 10. So this is 7.432 times 10 to the, it looks like 1, 2 places to the right, that will be a negative 2, because it's a small number, I need a negative exponent. So this is equal to this, in scientific notation equal to this, in scientific notation equal to this, in scientific notation, oops, and the last one is equal to the bottom there in scientific notation. All right, now let's reverse this. Let's go from scientific notation, or scientific form, to standard form. Well, scientific notation here in the first example, 1.05 times 10 to the 6. Now, because there's a positive exponent, we know this is a very big number. So what I'm going to do is I'm going to take the 1.05, and that tells me how many places I'm going to have to move my decimal point to the right to make it a big number. I'm going to need some zeros as placeholders, so I'll put a bunch of zeros down. I can always get rid of ones that I don't need. And I'm going to move it 1, 2, 3, 4, 5, 6 places. Don't need that 0, so that's 1, 2, 3, 4, 5, 6, 7 digits. That's 1,050,000. Over here, another positive exponent, so another bigger number. 3.1, I'm going to have to add some zeros as placeholders. I got to move it 3 places to the right to make it bigger. 1, 2, 3, that's what this tells me. So I can drop this 0 right here, and I have 3,100 as my answer. This one over here has a negative exponent, so that means it's going to be a small number, so that means the decimal point is going to go 4 places, but not to the right. That would make it big. I got to move it this way to the left, so I'll add some zeros, however many I think I'm going to need. And 4, I'm going to move it 1, 2, 3, 4. So I can drop this 0 right here. I like to have a 0 in the whole number spot. 1, 2, 3, 3, 2, 9. And there's my answer. Students will try to write this by putting the decimal point right there, but they'll leave the decimal point in the same form with all the little loops, and then you can't tell what the number is. It's best to rewrite it. And there's your answer. Now, I'm going to order these 3 numbers from least to greatest. 2 of them are in scientific notation. 1 of them is in standard form. I'm going to put them in standard form. So just like I did up here, 2.4, 5 places to the right is positive. 1, 2, 3, 4, 5. I'm going to have to put some zeros in there, and I get 240,000. Next over here, 3.3 times 10 to the 4th, 3.3, 1, 2, 3, 4. I'll put a couple zeros here, or 3 zeros there, and I have 33,000. And that's 49,000. So from least to greatest, it's this one, then this one, then this one. So I'm going to write 3.3 times 10 to the 4th. Now this one, 49,000. And then the last one was 2.4 times 10 to the 5th. And that's in least to greatest form. By putting them in standard form, it's much easier to compare. Now this last problem, it doesn't really have to do with scientific notation, but I want to make it into a scientific notation kind of a problem because we're going to be dealing with a pretty good sized number. A nickel has a mass of about 5.2 grams. What would be the mass in grams of $1,000 worth of nickels? Well, there's 20 nickels to $1. So if each one is 5.2, I'd have to multiply that by 20 for $1, and then times 1,000 for $1,000. All right, so now what I'm going to do here is I'm going to multiply 5.2 times 20. 5.2 times 20. That's a 0, a 4, and a 10 with 1 decimal spot. I get 104. Times 10 to the, times 1,000. Well, that's going to slide the decimal point, which would be right here, 3 places to the right. So this would be, with 3 places to the right, it would be 104,000, and this is in grams. I'm going to write this as, the decimal point would be right there. I'm going to scoot it to there. I have 1.04 times 10 to the 5th, in scientific notation there, grams. There it is in standard form. There it is in scientific notation. Now, I mentioned at the very beginning of the lesson that you can also use numbers in scientific notation to multiply and to divide. So I'm going to show you a couple of examples of each. To multiply two numbers that are in scientific notation, you multiply the two parts that are the numbers that are between 1 and 10 that can equal 1 but not 10. You multiply these two values first. 2 times 3.1 is 6.2. Now that's a number between 1 and 10, so that's good. And I'm going to multiply this times 10 because I'm multiplying these two. I'm going to add the exponents. 3 plus 4 is 7. And there's my answer that's already in scientific notation. This number times this number equals that number, all in scientific notation. I can change it to standard form if I choose to, but I'm okay with it right now. Now I'm going to multiply these two together. This one's a little different because I've added a twist to it. 3.5 times 4 is 14. That's not a number between 1 and 10. Times 10 to the, now what I'm going to do here is, because these are the same base, I'm going to add the exponents. That's a positive 4. But this answer is not in scientific notation because this number is not between 1 and 10. I would have to move the decimal point from there to there to make it between 1 and 10. 1.4. But if I make this smaller to balance it out, I moved it one spot, I got to make this one bigger. So times 10, add 1 to the exponent, times 10 to the 5th. So if you have to kind of finagle your values there so that they fit the form for scientific notation. Similar down here, instead of multiplying the numbers, I'm going to divide these two key numbers here. 4.8 divided by 2 is 2.4. And instead of adding the exponents, because I'm dividing, I subtract the exponents. They have the same base, times 10 to 4 minus 2 to the second power. Now that is scientific notation. That's between 1 and 10 times 10 to a power. Over here, I'm going to divide these two values. That will give me 0.8. That looks like trouble. Times 10 to the, and again, I subtract the exponents. This is negative 7 minus 6 is negative 13. So that's not in scientific notation because that's not between 1 and 10. It's smaller than 1. I would have to slide the decimal point over here. I would have to make this 8. Now if I make this bigger, I got to make this smaller. I made it one spot bigger, one spot smaller. So I subtract 1 from the exponent. That would be 10 to the negative 14 there. And that is in scientific notation. You can get good at this, and you'll see this again in Algebra 1 and Algebra 2 and such, but it does take a lot of practice, practice, practice.